we are, this is the point where we stopped on Tuesday, where we were talking about oversampling. When we oversample, and if the validate data set is not oversampled, then we don't have to do anything. You can just apply the model to the validation data set and everything is fine. But if the validation data set is also oversampled, then we have to adjust the numbers in the matrix, confusion matrix. Okay, that should be adjusted in this way. Okay, these are the actuals, the actual non-responders. Okay, in the whole data is 98%, and the actual responders, that is success or the event, positive event, that's 2%. But in the validation sample, if they are oversampled to 50-50, then we have to find a weight by dividing this 50 by the 98% and the 50 by the 2%, then we get the weights. And then we divide those weights into, so this is the actual 0 weight. Okay, so you divide that into the actual column, okay, and then the actual 1 weight, so which is that, okay, so that goes in the denominator for the actual column. So once you've adjusted, reweighted the numbers in the confusion matrix, then all the other computations fall in the way, follow the same formulas like before. So this is what we're going to do in R now. Okay, so we need these two libraries, and we're going to use a new data. So I have that here, oversample.csv in Canvas. So go ahead and download that. Okay, download that file. That's the one that has the rare case example. Okay, so I'm going to run that. Okay, and then read the data. Okay, so I will call it over S for oversample or over S.tf. Okay, so read.csv, and then I think it is and sample CSV. Okay, I got the data, and I hope you have as well. Okay, and now we can look at what we have. So we want to know what the prevalence is. Okay, what is prevalence? Prevalence is the proportion of positive class in the data. So now we have the over S, we can do a table of, okay, so there is a column called response. Okay, if you look at the data, so you see bunch of columns, and then the response column, that's our target. So we want to see whether the response is rare case or not. So we can do a table. So that gives us, okay, there are 5,000 zeros and then 250 ones. Okay, and we can also do, take the table. Okay, I'm going to replicate that line. Okay, and then there is a prop table, that is proportion table. Okay, so what this is going to do is it's going to take the table that's inside the parenthesis and do proportions. Okay, so if you run this, it's going to give you both the raw numbers as well as proportion. Okay, so how many zeros and how many ones, and what proportion are zeros, what proportion are ones. Okay, now rare cases, we have close to 5% positive cases here, so it's not really a rare case. Maybe in the borderline. Rare cases will be like 1% positive cases. That would be a rare case situation. But for us, we want to understand how to do oversampling, so the actual percentages do not matter. So we're going to, what are we going to do? How are we going to do oversampling? Okay, so I'm going to show you how to do the oversampling by ourselves. There are some advantages to that. And then there are a couple of functions in Caret library that's called upsample and downsample. So we will look at that. Okay, so there are two different ways, and they both, the first one that we're going to do by ourselves, you have more control over it. Okay, how you want to set up the oversample. Okay,